Processes session 2, part 5. We're looking now at paperwork and symbols. So at the end of this part of the session, I want you all to be able to state some of the key legislation and codes of practice for plumbing, name and describe various construction drawings, and identify from a photo various valves and also recognise the symbols for these. So paperwork. We've already looked at this in the comms module, communications module. There's lots of pieces of paperwork we need to be aware of as plumbers. I'm going to do a quick recap of these before we move on to the new parts. Well, legislation, that's law. The building regulations set out the legal requirements for building work, and the water regulations set out the legal requirements for hot and cold water systems. Codes of practice. Lots of codes of practice we need to be aware of. BSA 806, BSA 8558 are both specific to hot and cold water systems. 76BS 7671 is the main standard for electrical work, installation and testing. BSA in 12056 is the main standard for drainage, and BS 8000 covers workmanship. Some of the on-site documents we need to be aware of are our planning documents, which would be, which we're going to look at now. Job specification sets out who's responsible for each job and the standard it must meet. A schedule tells you what should be fitted in each property, and a programme of work sets out when the work will be carried out. I'm going to briefly look at some construction drawings now. Okay, scale drawings can be set out in lots of different ways. Could be site plans, floor plans, elevations, sections, and component drawings. Okay, site plan is a very, very zoomed out view of the whole site and the surrounding area, like you can see in the picture. A floor plan would be a view of one floor of a particular property from a top-down view. We might show where components might be, and can help you plan your runs. Sections, they're a sideways cut through of a building. Elevations are a view of the building from outside, so how it's going to look when it's completed. Schematics essentially show how the system works. So you quite often see these for electrics. You might occasionally see them for sort of heating systems. Yeah, basically shows how the system works. Okay, symbols. We'll often see symbols on drawings. Sometimes they look like what they represent, but more often than not they don't. And you'll notice a sort of a key theme. You'll see this sort of bow tie shape very regularly in a lot of our symbols, and it's a sort of general symbol to let us know it's a valve. Okay, so we're going to look at a number of these now. Firstly, a water meter. It's fairly easy. This one, it's a big M for meter in a circle. Water meters, they measure the volume of water that's been used by a property. Service valve, isolation valve. This is a sort of general purpose valve symbol. Okay, a couple of examples here. This is if you see this symbol, it's a general purpose valve symbol. It means that there's going to be a valve in place, a service valve or an isolation valve. Okay, stop valve. This is a stop valve would only use on high pressure pipe work. The reason for that is because the shape of it restricts the flow. You can see that the water would have to come in here and then go up and back down again. It can restrict the flow. It's quite good. We can use it in high pressure pipe work because it's got a rubber washer which screws down onto a metal seat, gives us a nice tight, watertight seal, even against high pressure. Looks a bit like this normally. Sometimes it's the same size both ends, sometimes it might be different size one end to the other, especially if it's been connected onto MDPE one end and copper the other, like this one would be. But this is a stop valve, and the symbol for it looks like this. It's like the bow tie with a big dot in the middle. That's a stop valve symbol. Gate valves we only use for low pressure water. The good thing about it is the gate sort of, when you turn the top, the head of the valve, the gate will sort of lift up to the full bore of the pipe. It's often known as a full way gate valve, which is good for low pressure because it causes a minimal disruption to the flow. The only problem is it's got a metal gate inside it which goes into a metal seating, which doesn't give a great seal, so therefore you shouldn't use it with high pressure pipe work or water. You should only use it with low pressure. It looks a bit like this, or exactly like this. This is a gate valve, okay, and the symbol is like this. So it's a sort of bow tie shape or valve shape with a big T off the top, which kind of represents the wheel head. Okay, drain valve looks like this on the right, and the symbol for it's like this on the left. You would use it immediately after a main stop valve or any low points in the system. Float operated valve, this one actually looks really quite like the valve itself, you can see. So if you've got a cistern or WC cistern or a cold water storage cistern, this would control how much water would flow into it. Single check valves, we'd use a single check valve where there's a small risk of contamination, or normally if you have hot and cold water mixing in the body of the valve, you should have a single check valve before the valve on both the cold and the hot. Double check valve, used where there's a slightly higher risk of contamination, normally on outside taps. We should see these fitted before an outside tap. And this is what the symbol looks like. It's basically just like a single check valve that you can see here, but two of them together. So single, double. Pump. Generally speaking, the pumps you're going to be seeing probably most on heating systems, but you could also use them on hot or even cold water systems sometimes if you've not got a big head of pressure to sort of pump the water to give you a boost. And the symbol for it is like this. It's a bit like a play symbol. That's the way I always sort of think about it. If you want the water to go, you get the pump with the sort of play symbol. Okay, motorised valves, a couple of different types of motorised valves. We've got 2-port valves, which you can see here. It's got sort of one inlet, one outlet, with a sort of square on the top to represent the motor, and a 3-port valve, which has got sort of one inlet and 2 outlets, again with the sort of rectangle on top to represent the motor. Okay, so 2-port valves, 3-port valves might come up in your heating test. Temperature pressure relief valve, again potentially could come up in hot or heating, or even in processes. Looks like this. That's a photo of it just there, and the symbol for it is here. Might be shown as a safety relief valve in your test. Okay, so this would be fitted on sealed heating systems, on sealed hot water systems, unvented hot water systems, and it's there to allow the water to escape if it overheats or if the pressure gets too high. Expansion vessel, again something else that would be fitted on a sealed heating system or a sealed hot water system, an unvented hot water system. And it actually looks like this. They can look different depending on what they're installed in. Sometimes they're flatter if they're installed in combi boilers, but generally they look something like this. And this actually kind of looks, the symbol for it really looks like what they are inside. They've got a sort of rubber diaphragm inside there. There'd be compressed air in here, and then as the water expands when it heats up, it would sort of push onto the rubber diaphragm, which would compress the air in the rest of the body of the vessel, and that's how it allows for expansion in sealed systems. Excuse me. Okay, and now it is time for your task.